Alright, note number 1.2, measuring length. Alright, so believe it or not, all the time you're solving for x in algebra, you're actually finding a geometric distance. So when these algebra problems are completed on a number line, you are performing geometry. So that's what we're going to be talking about with measuring length. Alright, so when we're given information on a number line, the number value that corresponds to a point, it's called its coordinate. So it's a coordinate point. So this is a coordinate point. So for example, coordinate A, this is 2 because coordinate A, 0.2, and coordinate B is 6. So coordinate B is at 6. So when we talk about distance in geometry, so when we're referring to distance, we're really referring to absolute value. So we're really referring to absolute value. So the length of AB, so the length of segment AB, so from A to B, we know it's 1, 2, 3, 4, so it's going to be 4 units long. Alright, so we can either say the absolute value of 2 minus 6, and the absolute value of 2 minus 6 is the absolute value of negative 4, which is 4. So it's going to be 4 units long. And then what is the length of the same segment if you measure the opposite direction? So if we go from B to A, so it would be the absolute value of 6 minus 2, which is the absolute value of 4, which is still 4. So you notice the length of AB and BA, it's still going to be the same. And then now if we remove the numerical coordinates and replace them with letters, so when we're talking about what's the length of ST, so the length of ST is the absolute value of S minus T. So the absolute value of S minus T. What is the measure in the opposite direction? Well, the opposite direction is just going to be the absolute value of T minus S. And how can we force it to be a positive value? To make it positive, that's when we use absolute value. So the absolute value of any number will make it positive. So number absolute value refers to the distance between these numbers. So now we have our definition of length. Alright, so if we have A and B points on a number line, coordinates A and B, the measure of AB, which is called its length, alright, is the absolute value of A minus B, or the absolute value of B minus A. So we have an example here. Find the measures of RS, RX, and XS on a number line. Well, if we start with RS, so we have RS. So RS is the absolute value of negative 3 to 7. So the absolute value of negative 3 to 7. So the absolute value of negative 3 minus 7, which is going to give us the absolute value of negative 10, which is 10. So RS is 10 units long. You can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's 10 units long. Rx, so if we look at Rx, here, so Rx, and then R is negative 3, so we want the absolute value of negative 3, and X is 1 minus 1, which is going to give us the absolute value of negative 4, which will be positive 4. And then the last one is X, S. So X is 1, S is 7, so the absolute value of 1 minus 7, which is negative 6, or the absolute value of negative 6 is positive 6. Then we get to segment congruency postulate. Alright, if two segments have the same length, they have the same length as measured by a fair ruler, then the segments are congruent. Also, if two segments are congruent, then they have the same length as measured by a fair ruler. So if we look at this number line below, which segments are congruent, Well, if we look at WX, so WX is 1, 2, 3 units long. So which other ones are 3? Well, 1, 2, 3, XY is 3 units, and then YZ is also 3 units. So we can say that segment WX is congruent. Now the congruent symbol, it's like an equal sign with a little wavy line over it. It's congruent to XY. It's also congruent to YZ. They're all 3 units long. So they are all 3 units long. So each one of these is congruent. And we can also use tick marks to show congruency. So what we want to do here, we have our rectangle. Well, we know that segment AB is congruent to segment DC, and we also know that AD is congruent to segment BC. So the tick marks will show that. Well, 1 and 1, that means these are congruent, and 2 and 2, that means that those sides are congruent. Now the segment addition postulate. Now that we understand congruency and length, we can put these components together. And I'm going to put them together to explore segment addition. The concept is as easy as it sounds. Alright, we're just adding the segments. So if point R is between points P and Q. So if here's our line, so here is point R is between P and Q. Well, here's P, here's Q, and then here's point R. So R is in between P and Q. What it's saying is that PR, well, here's PR plus RQ, so plus RQ is going to equal the entire thing. So it equals from P to Q. So PR plus RQ equals PQ. So that's the segment addition postulate. Now, our example here, if point M lies between L and N on a number line, if ML is 5 and LN is 7, what is MN? Well, what we can do here is we can draw our line. So it says point M lies between L and N. So point M lies between L and N. Okay? If ML is 5, LN is 7, what's MN? Well, what we know is that the whole thing is 7. Well, 5 plus what? 5 plus what is going to equal 7? Well, we can set up an equation, or we know that 5 plus 2 is 7. So MN is 7. MN is 2 units long. Alright, so 5, subtract 5 from both sides, so the value of MN is equal to 2 units long. And that is the segment addition, segment congruency, and measuring length.